Hey guys, today we'll be going over chapter 10. So in the past we've been working with plots and types of data. This time we'll be going into a kind of new topic, which is simulations and an introduction to randomness. So this is just a little baby step towards probability. So randomness, we think we see it a lot, but it's actually hard to get a truly random event. Like your teacher's random seeding charts are never truly random, and even the numbers that you get from random number generators out of computers, those are based off of seeds, and if you look at the algorithms, there is some order to it. So one of the true random phenomena would be nuclear decay patterns, and what we get from nuclear decay patterns is this thing called a random digits table. So this is a table of numbers from 0 to 9 that are in a truly random order. And that is what we have here. This is a random digits table, and it's a very commonly used one. You will see that each of these lines has a row name. So this is row 101, row 102, row 103. And then out here is our random digits. So there are 40 digits with 8 clusters of 5, so 5 random digits at a time. And then we usually use these when we do random simulations of events. So that is what we have here. The purpose of a simulation is to mimic some real-life event through using random numbers to represent the outcomes of some random event. So a word that you need to know is a trial. So a trial is every time that we run through a test of the simulation and then get some numbers. So for today's example, we'll be doing a simple one. We will be finding the probability that we will get heads when flipping a coin. So theoretically, the probability of that is 0.5, but when we run our simulation, it's like we're mimicking actually physically going and flipping a coin. So when we flip our own coins, when we flip it 10 times, we're not guaranteed that 5 of those exactly will be heads. There's always going to be some random variation in real life events, and that is what simulations are trying to do. So there are 5 steps of a simulation. Step 1 is to give an overview of what we're going to do. So in this case, we will say we are going to simulate flipping a coin, and getting heads. And then you have to give the probability that we'll get heads. So probability heads, the big P over here means probability, equals 0.5. This term over here is a notation that you'll see a lot from now on. Your P is read as probability of, and then what's inside your parentheses is the event you're talking about. So probability of getting heads is equal to 0.5. So this space is going to be a little cramped here, but it's essentially like this. First, we have to define our successes and our failures. So what we're looking for is flipping a heads. So flipping a heads is our success. And what we're not looking for, so flipping a tails, is going to be our failures. So define heads, and then in parentheses, success is equal to, and then we pick 5 numbers out of the numbers 0 to 9 to be flipping a heads. So for simplicity, I'll just say 0, 1, 2, 3, and 4. And now we have the rest of our numbers being our tails. So tails, which is our failure, is equal to the rest of the numbers. So 5, 6, 7, 8, 9. 5 numbers on each side. So now when we go through our table, if we get a number that is 1, that means we flipped a head. If we get a number that is 9, then that means we flipped a tails. And the second part of this definition is allowing or not allowing repeats. So this kind of ties to the real world in this way. So is it possible to flip heads more than once? The answer to that is yes. You can flip 2 tails in a row or 2 heads in a row. However, there are some cases when you can't have repeats. For example, if you're choosing 5 students out of a class and you're simulating which 5 students you're going to get, I can't choose the same person twice. So in this case, I wouldn't be able to allow repeats because I can't choose 2 of the same person. So in this case, we would allow repeats because we can flip 8 heads twice in a row. For our step 3, this is where we tie in our RDT, so our random digits table, into our simulation. So how are we going to read the RDT? So the main components of this are saying which row we're starting from, how many numbers we're looking at one time, so we could be looking at one number at a time, two numbers at a time, etc. And then when do we stop? So how do we write this? Using random digits table, row, and then if we come back here, in this case the first row is row 101, so we can just go with that. Row 101, and then coming to our definition, the numbers we use to represent our outcomes have only one digit, so 0, 1, 2, 3, 4, and therefore we're only looking at one digit at a time. And then we might as well just go to the end of the row each time, so until 40 digits, so that's how many numbers are in each row, are observed. So there are some cases when you would use 2 digits at a time. For example, if you had 100 outcomes, then you would use digits 00 through 99, so you would be looking at two digits at a time, so 01, 13, 14, to represent each of your outcomes. Next, we have our fourth step, so this one is actually running our simulation. The main idea is to run your simulation 3 times, so you will have 3 trials. Each trial you have to mention what row number you're on, and then you have to say how many successes you found, and then what percentage of the trial was a success. So we observed, in this case, we put in what our success was, so we observed our heads, that's what we're looking for. Looking at random digits table, row 101, let's see how many heads we get. We defined our heads as 0, 1, 2, 3, 4, so we have 1, that is a heads. 9 is too big because we defined our tails as 5 through 9, so 9 would be a tails, we don't want that. 2, 3, 4, so we have 4 heads here. We have 3 here because 9 and 5 are both tails as we defined. We only have 1 heads here because 5, 7, 5, 6, those are all tails. Now we have 2, 1, 3, so 3 heads, 2 heads, 4 heads, 1 head, 2 heads. So in total, if we add up all the total number of heads that we got, that gives us exactly 20 out of the 40 digits that we looked at. So we observed heads 20 times in row 101, and then we have to say what percentage that is. So 20 out of 40, which is equal to exactly 50%. You will not always get 50%, so just to change things up a bit, I won't go through the random digits table again, but you get the gist of what's going on, I hope. So for our second trial, let's say we got 22 heads. So we got heads 22 times in row now 102, and then we put it as a fraction, and then we give our percentage, which is equal to 55%. Again, let's do our third trial. So this time, hypothetically, let's say we got it 17 times. So we got heads 17 times in row 103, or 17 out of 40, which is equal to 42.5%. So now that we have all of the numbers that we need to conclude. So what did we get from our simulation? We say it like this: in my simulation, our success, so heads, occurred on average. We take the 3 numbers that we got over here, and then we average them together to get a total simulation average. So averaging them together, so 50 plus 55 plus 42.5 over 3, we get 49.17% of the time. And the expected probability, so that was given in our first step. Our theoretical or expected probability was 0.5, so 50%. Because when we flip a coin, we expect to see heads or tails, respectively, about 50% of the time. Now we have to compare how close was our observed probability to our expected probability. So we'd say the observed result is fairly close to the expected value, and then small differences can usually be explained by random chance or only running a few trials. That's it for simulation, so thank you for watching. I hope you learned something. Peace.